Hello there, it's Alana. I'm here to help you with this problem for statistics. Let's see, this is 12.1 number 7 in the study plan. Of course, where it falls in your homework or quiz is unknown to me. Now let's see, we're going to determine the chi-squared statistic, the degrees of freedom. Ooh, I better do the view and example part rather than the actual problem. Okay. So we have our outcomes A, B, C, D. We observed 51 in A, but we expected 100. We observed 46 in B, but we expected 100. This isn't going to be good. We observed 54 in C, but we expected 100. And then we observed 249 in D, and we expected 100. Not a good sign. Not a good sign at all. Okay, so we're going to need to find the test statistic, which is the chi-squared value. And we're going to do that. We can do that a couple different ways, but basically the long and the short of it is you take the observed minus the expected, you square it and divide it by the expected, and then add them all up. But there's an easier way to do this. Let's do StatCrunch. So let me make this a little bit. Actually, you know what? I'm going to copy this data. Oops, that's so small you can't really see it, but I can copy the data to a table, which was the second one. Here, let me make this smaller so you can see. Oh, for the love of goodness, it's just not going to do it on this screen. Sorry. Oh, if I make it there we go. There we go. Copy table to clipboard. Again, I just personally like the clipboard, but you can actually put it right into StatCrunch. But I like copying to the clipboard and then copying to StatCrunch because I want my StatCrunch to be in its own window, run by me rather than run by inside my math lab. That can get a little weird with the windows nesting inside of other windows. Oh, that's probably so small you can't see. Hold on, let me make this. I don't need to highlight that. Edit fonts and make these all 18 so you can see it better. Oops. Oh, and of course I hit one too high. There we go, 18. Update font. There we go. Okay, so I'm going to go to Stat. I want to go to goodness of fit test. I'm going to pick a chi-square test. And it wants to know where my observed is, which is in my observed column, where my expected is, which is in my expected column. Don't do any of that stuff. And then calculate. And it tells me the chi-square value is 296.34, which seems super high. Let's go back and see if this works. That's it. So they're just showing all the intermediate calculations there. But see the chi-square is when you add them all up, and that turned to 296.34. Okay, so we did it right. Beautiful. Wonderful. All right, so lovely. What else do they want? Oh, the degrees of freedom. The degrees of freedom are one less than the number of possible outcomes. So there were 4 possible outcomes. Outcome A, B, C, D, that's 4. 4 take away 1 is 3. And I believe the output has that. Yep, see there, degrees of freedom, 3. All right, all good with that. Then let's see what else do they want. So we figured out 3. Oh, there it is, 3. That's part B. And then part C is they want us to use a table or the technology to find the critical value to compare it with, because alpha was 0.05. Okay, so we're going to need to find the critical value 0.05. Remember that goodness of fit tests are always one-tailed, so because everything's squared, so everything's automatically positive. So it's always kind of right-tailed is the way we treat it. Hold on, let me grab up the notes to show that to you. There are the notes. So goodness of fit tests. Let me scroll. Oh, there it was. See that they're always right-tailed. That's just how goodness of fit tests work, because everything's always squared, so everything's always positive. So what they're asking us to do is really to find this value right here, the chi-squared alpha with k minus 1 degrees of freedom. Now you can do that from the table, or you can do it from StatCrunch. Actually, you can do it from Excel as well. So let me show you StatCrunch first. So let me grab StatCrunch. And let's see, I go to Stat, Calculators, chi-square. I want to tell it degrees of freedom is 3. And I want the probability to be equal to 0.05. And oops, and I want it to be going right-tailed because these are always right-tailed tests. And there they say it's 7.8. Let's see if that matches up with what this instructions. Oops, see, 7.8. Perfect. So StatCrunch found it beautifully for us. if I could grab it again. There it is. Okay, so I put my degrees of freedom here. I put my alpha right here. I made sure it was right-tailed because chi-square tests for goodness of fit are always right-tailed. There you go. All right, so then you would just ask yourself, hey, is 296 bigger than 7.8? Why, yes, indeedy it is. So we reject the null hypothesis. That's what they're getting at down here. Now, how else can we find it? In the table. So like on the exam, maybe you'll have to do it from a table. Well, a table's not too bad. So let me go here. So here's the chi-square table. You want to go to the 0.05 column, go to the 3 degrees of freedom, and there you go, 7.815. Right there. Let's see. Then Excel would be equals, let's see, chi-square at chi-sq.inv.rt. That's the new function. Probability is 0.05. Degrees of freedom is 3. And there you go. So that's another way to find it. So all of those ways are finding the critical value. So critical value. And remember your test statistic, which you found earlier, that chi-square value was equal to 296 point something. So really, really huge. Oh, let's see, where is it? Here it is, 296.34. And you can tell it's really tiny because your p-value is really, really small as well. Less than 0.0001. So very tiny, which means you're going to be rejecting the null hypothesis, right? So we reject H naught because the chi-square test statistic, which is equal to 296.34, is well beyond the critical value, which is also a chi-square, but it's chi-naught squared, or chi-0 squared, if you will, of 7.814 or 815. All right, there we go. Or you could also say because the p-value, which is the p-value method, is less than 0.0001, and that's less than alpha, which was equal to 0.05. All right, I hope that helps with that one. I'll see you back here for more videos.